Welcome back, guys. Today we're going to be having a look at Siemens PLCs, Remote IO, Profibus DP, and we're going to be having a look at how to create all of that within STEP7 Professional. We're going to be looking at controlling Remote IO from a Siemens S7300 PLC, as well as diagnosing faults within a Remote IO station. Let's get into it. So what we're connected to today is we're connected to an S7300 PLC, which is the PLC on the left hand side, and the PLC in question is a CPU 315-2DP. That DP there, decentralized peripheral, that there is our Profibus PLC. And at the bottom flap here, where our power supply is, as well as our MPI cable is, this is where the Profibus DP cable will also be going into. So there's actually two slots here, one for your MPI and one for your Profibus DP. And the remote IO station that we're connected to is this chap on the right hand side. If we look at the top left hand side of this remote IO station, you'll see the name IM151-1 Basic. That's the actual remote IO station that we're going to be using today, and this is the Profibus cable that we're going to be connecting to on the S7300 PLC to create that connection. Now, we've already discussed a little bit about the S7300 hardware. However, there is something different with the -2DP PLC that we've got here, and that is the extra indicators that we've got on the right hand side to the standard indicators that we had on the left hand side. You'll notice now we have an indicator for bus fault, and this is because, like I say, it's a Profibus PLC, and this here can work on a Profibus network. And if there is going to be any bus faults on this, we'll see this bus fault indicator appear from here. Now what we're going to do here is we're going to have a bit more of an in-depth look at this Profibus Remote IO station. So if I just go full screen on this, and what we're going to do is we're going to break it into sections. So here we've got our CPU, the IM151-1 Basic, and on the top of the CPU, the actual module here, we've got an SF indicator, a BF indicator, and our ON indicator. The SF is our system fault or our status fault, very similar to our S7300 PLC. We then have BF, which isn't battery fault but bus fault, similar to the one that's on our S7300. And we've also got our ON indicator, which is similar to our power indicator, telling us that we've got power to the actual remote IO station. Now, at the bottom of this IO station, you'll notice there's several dip switches here. And these dip switches are to identify the address of the remote IO station. If we just zoom in here, we can see that several dip switches are on the left position, but there's two dip switches here which are on the right position. This is the address of the actual remote IO station. Now if you look at these dip switches, the camera view that we've taken this shot on lies a bit, because this dip switch, which looks like it's on the same row as the number 1, isn't. It's actually at the very bottom here, which is looking at this indicator. And what this indicator does is tells the CPU whether to pull the address from the CPU itself or from the actual dip switches. And this is currently off at the moment, so it's not going to be pulling it on from the CPU, it's going to be pulling it from the dip switches. And if we look here, you can see that we've got two dip switches in the right position, and that is in position 1 and position 2. 4, 8, 16, 32 and 64 are all off. Now this is very similar to binary, because 2 and 1 are on. If we add these together we get 3. This is the address of this Profibus Remote IO station. It is address 3, so we must remember that later on. If I just zoom back out here, to the right of the CPU itself, we've got our PM module, which is our power supply module. And what this is going to do, it's going to supply 24 volts across this rack here. And you'll notice here at the very bottom, you've got your power indicator on. This there tells us we have got 24 volts going to the system here. If you don't have that green indicator on, check to make sure you get your power supplies wired correctly. To the right of this power supply module, we then have our IO modules. We've got a 4-digital input card, a 4-way digital input card. We've then got a 4-way digital output card, and it gets a little bit more difficult up here to try and identify what we're looking at. But if I zoom in, now I know this just off memory, but what we have is we have a 2-way analog input, and we also have a 2-way analog output card. The The writing that's actually on these modules has been worn off over time, but from memory I know what these two cards are. And if we look over to the left of the CPU here, we can see our Profibus head here. Now there's two different types of heads that we've got. This head that we're using here is what we call a piggyback head. And what this allows you to do is actually allows you to put on another Profibus DP connector on the back of this and sort of link off the back of it. Now this isn't what we would do on the shop floor. If we place a Profibus DP connection on the back of this Profibus DP head, this is what we call a spur. And what this can do is it can cause reflections on the actual transmission here. We don't do this on the shop floor. It's okay for classroom environments like this environment here, but if we're working with this on the shop floor, we wouldn't link another Profibus head off the back of this. So we don't want to do that. What we would do instead, if we wanted to link another Profibus station up here, we've got a Profibus cable coming into the bottom of this head, and you'll notice here you've got a green and red indicator just on the right hand side of the head. That there is for the two wires of your Profibus. So one wire, which is a green wire, will go into this terminal, and the other wire, which is the red wire, will go to this terminal. You'll actually see there is another set of green and red indicators. This is for your Profibus coming out. Okay, so if we wanted to link up another station, what we would do is we would wire another cable coming out of this head, and we would wire it up to those two terminals there. We wouldn't piggyback off the back of it here. Another quick thing to look at on the Profibus head is the terminator. And you can see here that you've got two positions. You've got an off position and you've got an on position. And at the moment, this red slide is in the on position, meaning that the terminator is on. And what that does is it stops the transmission of this signal at this point here. So if we did have another wire coming out of this plug here, the transmission would be broken. There would be no transmission coming out of that wire there. It would effectively be stopped, terminated. So when you see that terminator in the on position, that means that the transmission is stopped at that point. And what we do is we place that terminator on at the end of line. So it should be placed on at 2 points, the end of line and the other end of line here. If we have Profibus stations in the middle there, the terminators would be off, allowing the transmission to go through until it reaches the end of line. Now you'll notice at the moment on this remote IO station there's a lot of red indicators, and the reason why those red indicators are in place is because there's nothing set up at the moment. Our PLC behind us isn't set up for this Profibus station. What we're going to do now is we're actually going to go into STEP7 Professional. We're going to create a brand new project, set it up for our 315-2DP, this PLC over here, and then create a Profibus network for this remote IO station. So let's open up STEP7 Professional. And what we're going to do is we're going to create a brand new project. And we're just going to call this My Name Profibus. And let's just say okay to that. And a brand new project is going to open up. We're going to go to our MPI. And we're going to add a brand new station, which is going to be our Simatic 300. And there we go there. And we're just going to save that. And then we're just going to close that one down. What we're then going to do is we're going to open up our Simatic 300. We're going to open up the hardware. Go full screen here. Go full screen here. Just move down the details pane. And open up our Simatic 300 folder, and as we did in the previous videos, we want to create a rail first of all. So we open up the Rack 300 folder and we drag in our rail. We then expand that rail, and here we can see our rack. Now what I'm going to do is I'm just going to move myself out of the way for now. So now what I'm going to do is I'm going to minimize Rack 300. I'm going to open up my CPU 300 and I'm going to look for 315-2DP. And there's the folder there. Expand that, and if I just open up my image of the CPU, there's our 315-2DP, and the product code is your 315-2AF030AB0, and you can see here we have a folder, and if I expand that folder, it's asking us for the different type of version. Now the version is just underneath this flap. So if you lift up this flap, it tells you what the version number is, and the version number is a 1.2. I'm just going to drag that into slot 2. and it's going to ask you, do you want to set up your Profibus interface now? Now at the moment I don't want to set up the Profibus interface, I just want to leave it as a standalone PLC, because what I'm going to do is I'm going to create a little basic program, show you it working, and then create that same program for our remote IO. So I'm just going to leave that as not networked and just say OK to that. And then next what I want to do is populate the rack with my IO cards. If I open up my SM300 folder, expand my DI folder, I believe my first card is a 32-way digital input card. So if I just go down here, I should see 32-way digital input, DC 24 volt. And at the bottom of the card, it is a 1BL000AA0, which is that module there. Drag and drop that into slot 4. Go to my digital output card now, and what I want to find is digital output 16-way, and it wants to be our 1BH01. So if I look for DO 16-way, DC 24 volt, I need 1BH01. There it is there. Drag and drop that into slot 5. And what I'm going to do is I'm just going to save that, close that down, close this down now, I don't need that. And then I want to go back to my MPI NetPro window. I'm going to link the CPU up to our MPI network. You don't need to do this, but it's best to just go by the book in these things and just say OK to there. Now our CPU is linked up to our MPI network. Again, if you aren't too sure on how we did all that there, go back to our previous videos where we actually covered setting up an S7300 PLC within STEP7 Professional. Just save and compile that. Compile and check everything, say OK to that, no errors. Close this down, open up our Smatic 300 folder, open up hardware, and then just go full screen here. And what I'm going to do here is just save and compile my work and then download this to the CPU. Select view, select our CPU, and then we're going to begin downloading. Now remember, when we do a download of our hardware, what it's going to be doing first of all is stopping the PLC. So it's asking you here, do you want to stop it? Say yes, and what this is going to do, it's going to stop the entire system from there. Now again, remember, if you're working on the shop floor and you're doing this on a live PLC, you want to be very careful when modifying any sort of hardware. The reason for this is because you will stop the process stone dead. Now what I also want to do is I'm going to just check my clock memory inside of the PLC, because I'm going to use this to flash an output lamp. So to check my clock memory, I'm just going to right click our CPU, open up object properties, and then go to the folder clock memory. And you'll notice at the moment clock memory hasn't been selected, so it's not currently being used. Now what clock memory is inside of the PLC is it's a byte with 8 bits inside of it, all set to different clock frequencies. Now I've just checked the clock memory tick box here, and it's asked us which memory byte do we want to assign. Now at Scantime we tend to use memory byte 20. That's just a standard that Scantime adhered to. However, if you work on your shop floor, you might see that being a different byte altogether. Now I'm not going to go too in depth with these memory bytes and what each clock memory bit is, but all we need to know now is ours is set to 20, and there's 8 bits, 8 frequencies available to us. I'm just going to select OK to that, and because I've made a change to my hardware, what I must do is save and compile my work, and then download it back into the PLC. Now again, remember, even though we've just made a small change to the clock memory, I'm still going to need to stop the PLC from running. So again, if we're doing this on the shop floor, make sure that the PLC and the process is stopped. Say OK to that, and then yes, and let's start it all back up again. And now what I can do is just close this down. And what I'm going to do is we're going to open up my blocks, and I'm going to go into OB1, and I'm just going to say OK to that. And I'm going to create a very basic program, which is where I'm going to modify a bit, an internal bit from logic 0 to logic 1, which is then going to flash an output coil. So to do this, 2 normally open contacts and a coil. My first contact is going to be tied to M0.0, and I'm going to flash this every half a second. So I'm going to use the 1 Hz clock pulse. Now the 1 Hz clock pulse is half a second on, half a second off. and that there is going to be M20, because that's what our clock memory byte was set to, .5. And .5 is our 1 Hz clock pulse. It always is. So whatever your clock memory is set to, if you set it to 0, your 1 Hz clock pulse would be M0.5. And I'm just going to tie this to my first output coil, which is Q4.0. I'm just going to save that, and then I'm going to download that to the PLC CPU. Okay, that. And then if I just go to goggles there, and then what I'm going to do is I'm just going to modify M0.0 to a logic 1. And there we go. You can then start to see that that Q4.0 is now flashing every 1 Hz. It's half a second on, half a second off, which is 1 cycle of 1 Hz. Okay, now that we're happy with that and we know that we've got communications going to our PLC and we're actually able to flash the outputs here, making sure everything's talking and everything's working hunky-dory, what we're going to do is we're just going to come offline here and just close down OB1, and we're going to set up our Profibus network. So to do this, let's go back to our hardware folder, open that up, minimize our details again. And what we're going to do is we're going to set up a Profibus network. So to do that, right click DP and select Add Master System. And from here, where it says subnet not networked, it's then going to ask you to select new. And then what I'm going to do is I'm going to go to network settings, and you can see here the profile is DP, which is decentralized peripheral. That's what we're using, Profibus DP. And then the transmission rate, I'm going to leave it 1.5 megabaud. Now, on the shop floor, depending upon your shop floor, 1.5 megabaud may be too fast. Usually on the shop floor, what you would see the speed set to is 187.5 kilobaud. However, in the classroom, all I'm going to do is I'm just going to set this to 1.5 megabaud, and that there should work no problem with us. As I mentioned on the shop floor, you might want to reduce that transmission rate. Faster doesn't always mean better in this case. Faster speeds are okay for short cable runs. However, when you're dealing with long cable runs, the lower the speed, the better. And then just select OK. Now, once we've set that Profibus network up here, you'll notice the address is set to 2, and that's default, and that there is telling us our S7300 PLC's address is 2 on our Profibus network, which is fine. Station 1, address 1 is usually used for special equipment, so 2 is your default for your CPU, and we're just going to leave that and just say OK. And when you say OK to that, you can now see your Profibus master system is here, and this is our Profibus network. What we're going to do now is we're actually going to move our remote IO station onto this network here. If we go back to our remote IO station, you'll see at the top, its station is an IM151-1 basic. So what we need to do is go to our hardware catalog, open up Profibus DP, open up ET200S, and then look for your IM151-1 basic and drag and drop the entire station onto that network. Now it's going to ask you which network do you want to add it to, which is our Profibus network, the 1.5 megabaud, and the address of this Profibus station is address 3. Now remember, this is address 3 because our dip switches for this station are number 2 and number 1, which is 3. 2 plus 1 is your station 3 there. So select 3 and then just say OK. And you'll see there is our Profibus Remote IO station, and you can see in brackets it's station number 3. Next, what we need to do is then populate this rack with the correct modules. With our 300 PLC, all we did is we populated the rack from this location here. However, on our remote IO station, you don't get to do that. What you need to do is you need to select the station, and at the bottom, this is where we populate the rack. So let's open up our IM151-basic folder on the right hand side here, and then what we want to do is we want to look for our power supply module, which is PME DC 24 volt 4CA00. So if we go to our PM and we look for PME DC 24 volt, And I'm just going to move my webcam once again. Just move it up to the top again. There we go. You'll see here 4CA00, 4CA00, 0AA0. So I can drag and drop that into slot 1. Next, what I need to look for is our 4-way digital input card, STDC 24V, 4BD01. If I go to my catalog here and I just drop down DI, and I'm looking for 4DI DC 24V SD 4BD01. There it is there. I can then just drag that into slot 2. Our next card is the DC 24V 4-way digital output card, and that there is our 4BD02. So if I now go and look for my digital output, and I look for my 4-way DC 24V ST, there we go, and I'm looking for 02. There it is there. That's the guy. Drag and drop that onto slot 3. Next, gets a little bit more trickier over here. Again, I'll just move my webcam over here now. You've got your 2-way analog input, STU, and that there is 4FB01. So if I just grab my analog input and I'm looking for 2AUST, FB01, there it is there. Got you. And then finally, the extremely hard to see one, which I know is a 2AO, and that there is FB00. So we're looking for analog output now, 2AO, FB00. And then I just need to drag and drop that into place over here. So that looks like everything is set up correctly. Let's just close that down and let's go back to our Profibus station. Now if you look at your details here for your Profibus station and you look at your details for your S7300, what do you notice that could cause a problem? Now when I'm looking at this, I'm looking at the addresses, and if we look at the addresses here, you've got byte 0 to byte 3, byte 4 to byte 5, and then if we look at our remote IO station, we've got our input addressing starting from byte 4, and then we've got our output addressing starting from byte 0. The addressing is picked up from the main rack. Now really, what we want to do is we want to separate the addressing for our remote IO station as far away as possible from our main rack. And the reason for this is because what happens if we add more cards to this rack here, if we populate these other slots? Well, what the PLC will do is it'll automatically assign the addressing for the next addresses that are available. So if our remote IO station is then using addresses from our main rack, our main rack will then be using IO addresses from elsewhere, and then what you end up with is an absolute mess of addressing when it comes to it when you start looking at your main rack addressing and your remote IO addressing. Now if you remember from our very first video with Siemens, is every slot here is assigned 4 bytes. So this slot is byte 0 to byte 3, byte 4 to byte 7, byte 8 to byte 11, byte 12, byte 16, byte 20, byte 24, byte 28, meaning our remote IO station can start from byte 32. Now what you can actually do here is you can actually change your IO addressing for your stations by just double clicking the address cell and then going to the address tab. And you can see here it's asking you where do you want to start it from, and I want to start it from byte 32. So it's well away from my main rack. And then for the output addressing, I'm also going to start that from byte 32. And with Siemens you can do that. You can actually share the addressing numbers because the I's and the Q's differentiate the sort of address that we're working with. So now what I've got is I've got my main rack using bytes 0 all the way to bytes 31. So if I populate these slots here with any other cards, they will automatically be assigned the correct addressing. And then I've got my remote IO station using bytes 32 onwards. So here we've actually got some structure to our addressing. Let's just save and compile our work, and then download this to the PLC. Select View, select your 315-2DP CPU, and then download that to the PLC. It's then going to ask you, are you sure you want to stop the modules? Yep. And then, are you sure you want to start them up again? Yes. And then if we look at our remote IO station, you'll now notice there's no red indicators. Everything is green. Everything is happy there. And the PLC behind me also has no red indicators. Everything is green as well. So now I can then close down my hardware. I can then go to my blocks folder. I can then go to OB1. And now what I'm going to do is I'm going to create a network, and very similar to what we did with our CPU, I'm then going to pulse an output on my remote IO station every 1 Hz. So 2 normally open contacts and a coil, M0.0, M20.5, and then my very first output address is Q32.0. There we go. Download that to the PLC, and then go online. Now you'll notice, as soon as we went online there, the outputs begin flashing, and the reason for that is because that M bit was already modified to 1 from previous. So you can see here now our output Q4.0 is flashing, and our output on our remote IO station Q32.0 is also flashing. So what we've just done there, guys, is we've created a brand new project, created our S7300 rack, we then created a Profibus DP network, we then added our IM151 station to that network, and then we've controlled the outputs from that station through our CPU. And that there is your remote IO. So a main benefit with remote IO stations is the fact that we can greatly reduce the amount of IO wiring inside of the main panel. We recently just commissioned a job with a timber mill where we've refurbished an old Telemechanique PLC with a newer Schneider M580 PLC. This process is controlling over 1,000 IO devices. And if you open up the main panel, all you will see is the CPU and then some counter cards. There's no IO cards. And that's because what we've got is we've got remote IO stations located around the process line, controlling sections of that process line via their IO modules. And what this allows us to do is it allows us to greatly reduce the wiring. So now what we're going to do is we're going to cause a fault on the system. And the fault that we're going to cause is we're going to remove an IO module from the actual rack. So to do this, we're going to remove slot 4. And as we remove slot 4, you'll now notice that everything has stopped. There's no flashing going on. Your CPU indicator here has gone into stop. And if we look at our PLCs and our remote IO stations, we've got red indicators on them, telling us there's problems. And the red indicators that we've got here are bus faults and system faults. Now you'll notice once we've removed that card from the actual remote IO station, everything has stopped, including my main PLC. And this main PLC is controlling my entire production line. Now the only problem that we've got here is a slight disconnection on an IO card, but the entire production line is stopped, and that there could be a little bit risky. Now usually what you wouldn't want to do is stop the entire process because you've lost a few inputs on a remote IO station. What you might want to do is continue running the process but alert the engineers that there's a fault on a remote IO station. Now the reason why this has occurred here is because this PLC behind me doesn't have the necessary blocks to allow the PLC to continue running even if there's a Profibus remote IO station fault. Now we're not going to cover those blocks today, however there are blocks that will allow that PLC to continue running even if we have a remote IO station failure. All we're going to do now is we're going to identify that fault via STEP7 Professional. And to do that, what we're going to do is we're just going to come offline here, close down OB1, yeah, we can save the block, and we're going to go to the PLC folder. go to the PLC folder, go to Diagnostic Settings, and then select Hardware Diagnostics. And you'll notice when we open up our hardware diagnostics, we now have red indicators across the board. You've got a red indicator on your CPU, and you've also got a red indicator on your Profibus slave, which is address 3. So it even tells you the address of which has failed as well. Now, before we start diving into the Profibus slave, what we're going to do is we're going to open up our CPU module information and have a look at the diagnostic buffer there. And if we open up our diagnostic buffer, you can then see here we have a fault where it says that there is a stop caused by rack failure. And if we look at the description, it says here OB not loaded or not possible, and it mentions here rack failure OB86, and this is one of the blocks that allows the PLC to continue running even if we have a remote IO station failure. If we look to the next fault, you'll notice the event distributed IOs station failure, and if we look at the details on event, it actually tells you the station number that's failed as well, which is station number 3. So it actually pinpoints where there's actually a problem on your production line. So we know that we've got a fault with station number 3. Alright then. It doesn't tell us exactly what the fault is, we just know there's a fault there. So what we can do is we can close down the module information for our CPU and then open up the module information for our DP slave. And if we go to the DP slave diagnostics, what you'll now see is further down our diagnostic buffer is slot 4 faulty. And it says here slot 4 there is no sub-module. And this allows us to pinpoint exactly where the failure is on our remote IO stations. One of the biggest problems companies come across is when there's a failure with their remote IO stations, trying to locate that failure. Now, it's not too bad with our system behind us because we only have a CPU and one remote IO station, but as I mentioned before, we are controlling 1000 IO at this timber mill via 100 remote IO stations. What happens if one module on one of those remote IO stations fails and you don't have a PLC to try and identify where that fault is? Well, you can be searching for a hell of a long time trying to find that faulty station. With this programmer here, we can actually just dive into the diagnostics and identify which station has failed and which slot on that station has failed. And here it says slot 4. So what we're going to do is we're going to repair that fault now. And there we go. What we've done, we've just placed that IO module back into its station, and the bus fault, system fault from our remote IO station has reset, and the whole process is looking healthy again. My PLC behind me, however, is still in a system fault mode and it's still stopped. What I need to do is start this PLC to allow it to clear the fault. And there we go there. Everything now on our production line is looking healthy. And if I just select update on my hardware diagnostics, you'll then see those faults clear. I can then close that down, open up OB1 again, go to monitor mode, and then I can view this station online running again. And that there is Profibus and remote IO stations within Siemens PLCs using STEP7 Professional. As I mentioned, it's just a basic look at this. All we've done here is just create a basic project, set up a DP network, assigned a remote IO station to it, and controlled IO from that, as well as creating faults and diagnosing faults on those stations using the diagnostic buffer. If you want to learn more about this Siemens S7300 PLC and STEP7 Professional, you can do so online via our online courses. And what it will do is it'll cover S7300 PLCs and STEP7 from the absolute basics to the more advanced side of STEP7 Professional and S7300 PLCs using things like function blocks, functions, data blocks, VAT tables, etc., creating programs from that. If you're more interested in attending hands-on training, we also have our EAL Siemens Industrial Maintenance and Fault Finding Professional, which teaches you how to work with these PLCs physically on the shop floor safely and efficiently, as well as fault finding on these PLCs similar to what we did before, but a little bit more in detail, giving you that hands-on experience as well. I hope you've enjoyed this introduction to Profibus and remote IO stations, and I'll look forward to seeing you again.